Hello everyone, my name is Christine G and I'm going to be going over this. It's from Mod 5, it's problem number 9, 11.2.13. Now these numbers can change, so you could still have, problem number 11 is the same as this, or a different, I think this number is supposed to say consistent, so you might want to look at that. So here, this problem, we have a manufacturer of hardness testing equipment, and they use steel ball indenters to penetrate metal that is being tested. And the manufacturer thinks it's better to use a diamond indenter. And so what they're going to do is look at the differences between the two types. They have a metal one and a diamond one. And in doing that, we're asked to construct a 95% confidence interval to judge whether the two inventors result in different measurements, where the differences are computed as diamond minus steel ball. So let's go ahead and take a look. We can pull up the data here. And right away, I notice, these are paired samples. So we have specimen 1, 2, 3, and they're being looked at individually as pairs. So we want to look at that when we open StatCrunch, where we're going to be doing the confidence interval. Let me go ahead. So here we have the information, and I'm going to put it over here, and we're going to compute, we're going to use t-stats and paired. As I mentioned earlier, the numbers go together per specimen or per sample. They're matched together. So now this is the tricky part. Here it tells us we have diamond minus steel ball. Now we're going to be doing a confidence interval, so diamond minus steel ball. So mu1 sample needs to be diamond and then minus steel ball. So now we are ready to compute this out and get our lower and upper limit. So the lower bound, and we're rounding to the nearest tenth as needed, and so we can see that looks right on track, 0.2, and then the upper bound is 2.9. So that looks perfect. Now, when we have a confidence interval, so what this actually means is that we're 95% confident that the mean difference is between the lower and upper bound. So here we can use that to help us with the next question, and you'll notice that 0 is not within the lower and upper bound. 0 comes before 0.2, and then of course this is almost at 3, so it's way above 0. So what that means is that the mean or the difference, it's not as likely that the mean difference is at 0. And what we can take from that is stating the appropriate conclusion. We look at that and we can say that there is sufficient evidence to conclude that the two indenters produce different hardness readings, because we don't have the mean difference between the two being 0 from what this confidence interval is showing. So if 0 was within it, then it would be more likely that there was no difference or insufficient evidence that the two were different. So let's go ahead and check that and see what we come up with. Yep, so that looks good. So Thanks so much for watching, and if you have questions anytime, reach out to me. Again, Christine G, and thanks for watching. Have a great day.